Hello, Algebra 2. Here we are with a review worksheet for spring break. Hopefully trying to keep you fresh on your knowledge here of trigonometry over break. Let's take a look. Complete the following quadrant of the unit circle. Okay, so on your test, you're not going to need to know the entire unit circle, but you are going to have to know one piece of it. Probably not going to be quadrant 1. Probably going to be quadrant 2, 3, or 4. Okay, so I don't care how you get your information in here. Just try to squeeze it in here. So we have 90 degrees, 120 degrees, 135 degrees, 150, and 180. If we're doing our radians, we got pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And our coordinates. Up top here we got 0, 1. Then we'll have negative half, positive radical 3 over 2, negative radical 2 over 2, comma positive radical 2 over 2, negative radical 3 over 2, positive a half, and negative 1, 0. Okay, those are itty-bitty, tough to see. Okay, you can refer back to your own unit circle if you're having trouble reading that. Or on Schoology, there should be a PDF of a completed one with relatively nice handwriting. Number 3, given an angle, find the trig values. Okay, and then there's a little circle there. If you need to sketch it out, that helps me sometimes. So 2 pi over 3, I know, is up here. And that's going to help me with my coordinates. I'm not very far over, and I am more up. So I know it's negative half radical 3 over 2, which is also up here. Remember, it's cosine, comma sine. So sine is the second one. So we got radical 3 over 2. Cosine is negative a half. Tangent, maybe do a little work over here, is sine over cosine. Sine over cosine. Okay, fraction divided by fraction. Change it to multiplication and flip it. Okay, our 2 on top will cancel out the 2 on the bottom, and we'll just have negative radical 3 over 1. Okay? Now for the reciprocals. We're going to flip these. So when I flip the 2 over radical 3, now the radical 3 is on the bottom. That's no good. Okay? So I need to do the fix-it trick. We're going to multiply radical 3 top and bottom. And we'll have 2 radical 3 over regular 3. When I flip negative half, it's going to be negative 2 over 1. Or just negative 2. And when I flip negative radical 3 over 1, we'll have to fix it, and we'll get negative radical 3 over regular 3. Okay, take a look at that. Number 5. Ooh, negative rotation. So we're going to rotate 3 pi over 4, but instead of rotating up, we're going to rotate down. So negative 3 pi over 4, we're going to go backwards. There'll be 1, 2, 3 pi over 4. That would be the same spot as positive 5 pi over 4. So if that helps you to add 2 pi to get it back positive, you can certainly do that. That's negative radical 2 over 2, comma negative radical 2 over 2. Alright, so our sine is negative radical 2 over 2. Cosine is also negative radical 2 over 2. And tangent should be 1, because it's going to be this negative radical 2 over 2 divided by the same thing. And something divided by itself should be 1. Okay? When I flip this, we will have negative 2 over radical 2. I like to keep the negatives on the top. Now the radical 2 on the bottom is a problem, so we're going to multiply radical 2 top and bottom. And we'll have negative 2 radical 2 over regular 2. The 2's cancel out, and we'll have just negative radical 2. Negative radical 2. Okay, secant should be the same thing, so instead of going through all that work again, we're just going to write negative radical 2. And cotangent, when I flip 1, it's going to stay at 1. Okay, some tough ones there. Backside. Drawing the point. Negative 3, or 3 left, and then 2 up. So we got negative 3, comma 2. There's my theta. Alright, little a squared plus b squared equals c squared. 2 squared plus negative 3 squared equals c squared. 4 plus 9, we got 13. And when I square root, we'll get the square root of 13. So sine is going to be 2 over radical 13. Okay, again, we don't want the radical on the bottom, so you're going to multiply top and bottom by radical 13. And it'll be 2 radical 13 over regular 13. Cosine would be negative 3 over radical 13. And then with the radical on the bottom, we multiply top and bottom by radical 13. And we'll get negative 3 radical 13 over regular 13. Tangent, opposite over adjacent. We'll have 2 over negative 3, or negative 2/3. When I go to do these reciprocals, instead of looking at this one, I'm going to go back here, because the radical on the bottom was a problem for this one. But if I flip it, now the radical's on the top, not a problem. Radical 13 over 2. I like to keep the negative on top, so we'll have negative radical 13 over 3. You could also have square root of 13 over negative 3. And this one's going to be negative 3 over 2. Okay? Finding the angle. You might have to use your brain a little bit. Okay, I'm going to do tan inverse because I don't want to have to use a radical sign. So I'm going to do tan inverse of negative 2/3. Second, tan negative 2 divided by 3. Okay, negative 33.69. So that would be here, negative 33.69. What is the actual angle? How many degrees are in that gap? Inside that gap right here would be 33.69. So that is the angle. Okay? If we did another one of them, you might have like 150 something. Well, 150 gets me to here. What's the gap to the closest x-axis? And that would have been 33.69. So you have to use your brain a little bit with those. Stop by in between passing periods and you can check what you need to get to class. Converting radians to degrees, degrees to radians. We got a somewhat friendly one. 7 pi over 6. When we have radians, we're going to go to degrees. We multiply by pi, nope, other way around, 180 degrees per pi. The pi's cancel. And we do 7 times 180 divided by 6 for 210 degrees. Okay, 300 degrees, we're going to multiply by 100, I did it backwards again, pi over 180 degrees. So then you can think about it as the degree signs cancel out. We have 300 pi over 180. Now here's the hack. 300 divided by 180, and then math, frac, and it reduces the fraction for you to 5/3. So we'll have 5 pi over 3 radians. Okay? 2 more nice ones. 2 not friendlies. Okay? These won't work out perfect. You will need to round to 2 decimals. We're going to multiply by 180 degrees over pi. The pi's will cancel out. And we'll do 19 times 180 divided by 24. All right, thank you, Dr. Gustafson. So we have 19 times 180 divided by 24, and we'll have 142.5 degrees. So these might not work out perfect. Okay, 302 degrees. That's not on the unit circle. That probably won't work out perfect. So times by pi over 180. 302 pi over 180. Okay, we're going to reduce. 302 pi. Nope, we don't need the pi. 302 divided by 180. And we can go math frac. That would reduce to 151 pi over 90. That's not that helpful. That's not that helpful. Okay? Because those are not on the unit circle, so that's not helpful at all. So here's what we're going to do. We're actually going to multiply it out. 151 times pi divided by 90. And we'll have 5.27 radians. Okay, if you have pi in the answer, like we have the one above it, okay, that's obviously radians. I'm going to know it's radians. When you change it into decimal, 5.27, I don't know necessarily that it's radians anymore. That could be degrees. Okay, so we need to write radians. If we're going to multiply pi out, which on the ugly ones, let's multiply pi out and round it to 2 decimals. Okay? There we go. Hope that helps, kids. Best of luck. Enjoy your break. Stay sharp, and we'll see you on Monday.